Hey everybody, my name is Leon Hamilton with the NetworkGoldStandard.com. I'm bringing a tutorial to you today about subnetting. I'm going to be teaching you a cheat sheet that I learned some time ago that helped me solve subnetting issues fairly quickly. You must have an intermediate level of knowledge with subnetting in order for this tool to be used to its highest potential. If you know your binary, this is definitely going to be something that'll help you out if you understand subnetting on that level. So as you can see, I've got a cheat sheet here that's got two things going on. This chart over here on to the left has numbers 1 through 8, which is going to be our network subnets. And then in the middle here, we have our subnet mask. And then our third is going to be our host bits, number 7 down to 0. And there's a method to my madness. You'll understand in just a moment. And then over to the right, we have our powers of 2. So that's how we solve these issues. So we've got our powers of 2 and what they equate to over to the right of those. So right now I'm going to throw out a couple of questions to get you a little bit familiar with how this actually works. So right now we're going to deal with the Class C address. And so let's throw out something like, what is the subnet mask needed to give at least 12 hosts per subnet? Okay, so we know we're dealing with the number 12. We're going to go over to our powers here. Does 12 fit into 8? No. Does it fit into 16? Absolutely. So 2 to the 4th power equals 16. So this 4th power right here, this is our magic number. So we're going to take that 4 and we're going to look for the 4 over here in our host bits. 4. So to the left of that, we've got our mask. So we know our mask is going to be 240. So the answer to this question is 255.255.255.240. And that solves that one. So you see how easy it is? You just kind of have to look at what your powers equate to, what the power is, and what the magic number is to that power, and go over to our chart to the left to figure out the rest. And that's for the host. Let's throw out another one. And this is going to be another Class C. What is the subnet mask needed to give at least 50 hosts per subnet? So we know we're dealing with the number 50. So let's look at our powers. Does 50 go into 32? No. Does it go into 64? Absolutely. So 2 to the 6th power equals 64. So 6 is going to be our magic number. So we'll go over to our host bits and we look for the number 6. And we know our mask is going to be 192. So for this being a Class C, it will be 255.255.255.192. And that's the answer to that question. That's how we get at least 50 hosts. All right, so let's go to another Class C. All right, so what is the subnet mask needed to give at least 20 subnets? So this is going to change up a little bit. So we know we're dealing with the number 20. So does 20 go into 16? No. Does it go into 32? Absolutely. So the powers for that is 2 to the 5th power, 5 being our magic number. So instead of going over to the host bit side, we're going to go over to the subnet side. So we're going to look for our magic number of 5. So 5 right here. So our mask is going to be 248. So for this equation, it's going to be 255.255.255.248 to get us at least 20 subnets. So our next question, let's go into some Class Bs. Let's try that. All right, for our next equation, we're going to be dealing with a Class B, and what is the subnet mask needed to give at least 100 networks on a Class B address? So 100 networks. So does 100 go into 64? No. Does it go into 128? Absolutely. So our powers are going to be 2 to the 7th power. So 7's our magic number, okay? So we're going to come over to 7 on our subnet side, which is going to be 7, and our mask is 254. So for this answer, it's going to be 255.255.254.0 to get at least 100 networks. All right, so we're going to deal with a Class C address with a CIDR 27, which is a 27-bit mask. So what can we do to get at least 6 subnets with a minimum of 20 hosts per subnet? So since we know we're dealing with the number 6, does 6 go into 4? No. Does it go into 8? Absolutely. So 2 to the 3rd power is 8. So our magic number is going to be 3. So we'll go over to our subnet side, and we know that our number is 3, and it's going to be 224 as our mask, which is a CIDR 27 with 5 host bits left over. So what we're going to do, we're going to take those extra 5 bits and we're going to look for the magic number here. 2 to the 5th power equals 32. So that's our 32 host. So we've got 6 subnets and enough to have 20 hosts, which we ended up with 32. So now we'll deal with a class B. And in this equation, class B, what is needed to yield 50 networks? Alright, so we know our number is going to be 50. So we come over here, we know that 50 will definitely go into 64 and it won't go into 32. So 2 to the 6th power is 64. So our magic number is going to be 6. So we're going to go over to our subnet side and we've got 6. And our mask is 252 with a leftover of 2 host bits. So in this equation, our answer is going to be 255.255.252.0 to get our 50 networks. Now, we're going to take the 2 leftover bits and combine them, or the 2 leftover from our 3rd octet with the 8 leftover in our 4th octet now. We're going to know that that's equals to 10. So we go down to our magic number here of 10 to the 10th power, and we have 1,024 hosts left over, and we will have our 50 networks. Alright, so I hope that was easy enough. I hope I gave enough clear examples for you to be able to utilize this tool and figure out your subnetting as fast as you can. Kind of a cool cheat sheet. After a while, if you've done this long enough, you'll be able to do this off the top of your head for most of these subnetting questions. But this is just a really neat guide or cheat sheet for you to use. Before taking quizzes, when it's that time to write down notes, I try to write that down. It's the first thing I write down so that when I come across subnetting questions, especially if I'm timed, I'm able to get through them pretty quickly. So, yeah, hope that helps you guys a lot. My name is Leon Hamilton with the networkgoldstandard.com, and I'll see you later.